start?
Yeah, okay, I will start. Very good morning to all the participants. Again, greetings from St. Xavier's Catholic College of Engineering, Nagercoil. I am happy to welcome you all for the second day of the 1 week hands-on workshop on image processing using MATLAB, which is organized by the Department of Computer Science and Engineering and the Department of Information Technology. Yesterday, we discussed about what is an image processing and what is a MATLAB and what the matrix operations in the MATLAB, and we were discussing about the image arithmetic. And also we shared a link to you regarding few few programs related to image arithmetic operation. I hope you have gone through that link and executed the programs also. So today we are going to discuss about the pending arithmetic image operations, that is image arithmetic operations, and the day 2 content of our program, that is the gray level transformation and image enhancement. So as yesterday we had some theory session, but today we don't have enough time to go for theory session. So throughout the session it will be a practical oriented hands-on training. So the trainer, that is a resource person, Dr. Seldev Christopher, will be explaining how you can go for that. And during your free time after this workshop also, you can execute the programs which were already shared to you. Again, I will be sharing the program link to you. Please check the chat window. In the chat window, I am pasting the link for all the programs of day 1 and day 2. So please bookmark this link. Through all the programs will be updated in this link throughout this 1 week. So you can bookmark this link and you can verify that. After that workshop also, you can go through this link and copy this program and try executing this, so that you can understand the workshop very well, or the concept of the MATLAB, concept of image processing in MATLAB can be learned very easily by going through or executing these programs. With this small introduction, I am not taking much time because a lot to cover today. So I request today's resource person, Dr. C. Seldev Christopher, to start his presentation. Welcome, sir.
So good morning, sir. Good morning, all. Let me start from basic MATLAB. Since yesterday some asked about how to do some processing or image, how you can read. That itself, it's confusing for someone. So I'll start from MATLAB. I'll open more MATLAB now. Whether you are able to see MATLAB?
Yes, sir. Yes, sir. Visible. You can
visible.
Proceed.
Yeah. So I will show you. So here I have given a small program here, right? So here, yesterday someone asked what are the things available in MATLAB. That I must say something about that, right? See here in the top left, top corner we have the menus: home, plot, apps, editor, publish, view. So there are 6 things are available. So actually MATLAB is not just for image processing. So I'll show you what are the things available in MATLAB. For that, if you go to help in the documentation, are you able to see this documentation? Help window, are you able to see? Anyone? Andrew, sir?
Yes, sir. Yes, sir. I can see.
Help window, are you able to see, right?
See, I request the participants to interact with the resource person through the chat window. So only the resource person can understand whether you are following the topic.
Yeah. So this is the help window. There you can see what are the toolboxes available. See in the left side. So there are a lot of, yesterday I told you, all the engineering fields are available in MATLAB. So you can see all the fields here. from finance and mechanical, civil, yeah, and even for management also, it is useful, management tools.
Seldev sir, that window is not visible to us.
Yeah, not visible.
Yeah, because that may be another window. Yes.
Yeah, yes.
So you can share that. Otherwise, you can share your desktop.
Okay, okay.
You can stop sharing this and you can share that window.
Okay, okay, sir. Now,
yeah, visible, sir, visible.
visible. So, right. So, how you can get it with this from the MATLAB home? If you have go to help documentation, so we'll get this one, right? So here we can see all the things that what are the toolboxes available here. See what are the toolboxes available here. I'll just open image parsing toolbox, right? Here, so image parsing is just a simple part here. So here we can see what are the functions available in MATLAB. Yeah, see what are the functions available. Almost all the things what you have studied in theory, all are available in MATLAB. So image type conversion from color to gray, or from RGB to indexed image, or from grayscale to binary. So all this are available there in the MATLAB. The interactive exploration, build exploration. So if you know first generally about MATLAB, about image parsing, then only you will understand all the things here. Otherwise, you'll never understand. Just you'll take it from this. What the output you got, you'll say that is output. So actually, what that does, you'll never know, right? So first, you must know the theory first. Then only you'll understand what are the things that particular things will do, right? So these are help. So you can, if you want some help here. So if I want to read, I am read, right? So if I right here, you can see I am read. So I'll get with help with some example. I'll get how you are how to read and how to index it, right? So all this will are available in the help. Now I'll tell you about some MATLAB basic one. So here, even though several things are available here, since MATLAB does not support, I told you, does not support image parsing alone, it supports several things. And GUI can also be created using MATLAB, GUI, graphical user interface, or Simulink. That is, we can publish Simulink means you will have a block-like structure, which can be also be used for simulation, but that will be somewhat different, Simulink, right? So now you are just going for image processing programming. So if you've done good thing in image processing programming, at last you can show outside as GUI. So now I'm not going to concentrate on GUI. So here import data, save work file, several things are there. When you are going for many very hard processing, all this will be useful for you. Just a new script means all this will open. Yeah, untitled, that is script editor will open. From that you can save a program and you can run, right? So all the plots you have. So these are all the plots. Normally when you are going for plotting as a graph, so this will be useful. So which graph you want to plot, and several apps are there. So this will be useful for interactive apps, means that online processing. If you do, or when you are having a camera, you take that from the camera, you want to capture the data. That's what you will have here, image acquisition. Straight away you can do it from there, right? So for that you will have this one. And for editor, this is what normally you'll use. This is what you'll have, this run and breakpoint command. All this are available only in this editor window. Here only you'll run the program. So I have just given a 6-line program. You may be understanding what is CLC. CLC means clear command window. Yesterday I told you close all means if any window is open, you have to close. Clear all means you are going to clear the workspace. Just I am reading a peppers.png. Someone's asked, suppose I want to read an image, whether the image must be in my folder, right? So what happens is, if the image is in your folder, you can just write the name and extension. If that, so this is the image available in MATLAB. MATLAB also has some images, right? So these are the images available in MATLAB. So in the program execution, what are the sample programs all I have given you, all the programs, the images are available in MATLAB. That's what I given straight away the image name there, right? So all that will be executed automatically. No need to copy any image, right? So here I have given a peppers.png and I am showing that particular image. Then I am converting that image to gray image. That's what RGB to gray. RGB to gray means it will convert the RGB image to gray image, and just I am showing. And for getting a loop for doing any operation, you need for loop for processing an image. In such cases, you need a size of the image. So I'll just tell you that I'll just run the program, right? So first I have to save. I have saved there in desktop. So I am just running the program, right? So you can see this is the color image I have given. I have converted into a grayscale. So though both windows have opened. Since I given here, I am show outside. So if you want to, if you are just not having this figure, automatically it will be overlapped. Just you can see, just you can get only the grayscale image, right? See only the grayscale image, since that will be overlapped. So to open a new figure, just I included the figure, right? So at last you can see here in the command window, the size occurs like this: 584, 512, and 3. So this 3 denotes it's a color image, right? If it's 1 means you can say this is a grayscale image. Why you are having the thirds is, since I have not given a semicolon here, the size is displayed here, right? So this will be the size 384 cross 512 cross 3. That denotes each pixel has three colors, right? Each pixel has 3 colors. That's what the meaning of this one, right? So now I'll read an image from somewhere in the computer, right? So I have given, I have taken one image I am having in my computer. Just in such cases, what you have to do is you have to give the location. So in E, the location, the image.jpg. So now I will run that program, right? So this is the image I have taken from my computer. So when it is somewhere in my computer, we must give this all the address, right? So for that only, yesterday I have given you some technique that's automatically computer will ask you. So for that, right, I included this one. So for making a line into a command, just you have here, if you put a percentage simple, automatically it will be a non-executable statement, right? So again, if you want to uncommand, we can do it here. Command, we have to do it here, right? I'll run this program. Now you can see what happens. So it asks you from where I have to take that particular image, right? No, I'll take some screenshots are there. No. Then I'll take it from my computer somewhere else, right? right? So it takes from my computer. So from any space, in any folder or anywhere in computer, we can select using this. So how it works is, so you are giving file name, come up path name. That automatically takes UI get file means it will automatically take the image. No need for this pick a image. This is just for you. So you just star means it will pick any image. If you have start.jpg means it will take only JPG image. Then you are reading that path name comma file name, right? Same thing. If you want to see the pixel value interactively, so for that only yesterday I have given, but so what you have to do is you have to include IM tool, right? So what you have to do is you have to type IM tool of, so earlier I have in some variable A, isn't it here? So I'll put enter, right? IM tool of A. So automatically that image opens, right? So now we can see if you move the cursor, so in the bottom you are able to see pixel information, X, Y, and RGB, right? So XY denotes the where you are moving, the location, and RGB means the pixel value. So wherever you move, you can see the values. So you can zoom up to the, so you can see in the edges only we can see the, right? So this small block is 1 pixel, right? Are you able to see, right? So this is what it makes an interactive tool. This normally don't use IM tool inside the program, right? After execution, if you want to see, you can type it in the command window and see. Since the IM tool will never close. Close means if you have to close manually. Otherwise, what happens? You are using close all, isn't it? So in the program, if you use close all, automatically all the windows will be closed. But the IM tool, if you open using IM tool, it will not be closed. Another one thing, see here, the several warnings will come. If the size of the image is so high, the warning will come. Since that the image cannot be fit in your screen, only 17% I have given. So the maximum image size that will be fitting in your MATLAB window is 299 cross 299. So it's better to have that size. Whenever, so you can have bigger size, but execution time will be more, right? So this is what I want to tell you, a general introduction about this particular MATLAB, right? Now we'll go straight away to our topic. So I'll now stop sharing and I'll share the PPT, right? Are you able to see that PPT image enhancement?
Yes, sir. Visible. You can proceed, sir.
Yeah, yes, sir. Right. So here you are going to see now today image enhancement. That is some gray level transformations and how they are doing enhancement. So first we must know what is enhancement, right? So enhancement means just that is for a particular application. I want that particular area clear. Means you have to enhance only that particular area. No need to take care of all the other things, right? So in some area, in some image, you have to make the appearance clear, the whole image clear. So in such cases, the whole operation will do, right? So that's what you have. The image enhancement means to bring out details in absurd or simply to highlight certain features of interest in the image. That's what. So here we can say see some dots here. That is removed here. This is one type of enhancement, right? So the two main concerns of any document imaging is quality and file size, right? So what happens is if you are doing enhancement, suppose what happens is if you are increasing the quality, the file size will increase. So what happens? You must compromise, right? So if you want both must be optimum. That's what normally you'll go for this programming side in order to have minimum file size with good quality. So that's what that's the main scope of image enhancement. So these are some of the causes of degradation: poor contrast, electronic sensor, aliasing effect, so aperture effect, all depends upon the camera, right? Camera and the lighting system, right? So in a spatial domain, we can have can write it as g of x comma y as some image. You are giving some transformation t on that image to make it into or enhancing the image. That's what you call as transformation here. So what are the normal transformations available? So we are going to see about this 5 transformation: image negative, log transformation, power law transformation, gray level slicing, bit plane slicing. So what is my image negative? You may be knowing image negative of the image, right? Previously, when you are doing the photography, first you will get the image negative. From that negative only, you will take the photo, right? A photo print, right? So here, what that particular, how you are getting the image negative. See, this is the original image, and this will be the negative. So what happens if this will be the input gray level? When you are having high input gray, the input gray level is high, the output gray level will be low. If the input gray level is high, the output gray level will be 0. So that's what we'll have. So general formula is, so you can have this S equal to L minus 1 minus R, where S is the value of the processing pixel, R is the value of the input pixel, and L is the level, how many levels you have. So normally for ordinary images, how many levels you have? 256. They are representing by 8-bit, so you'll have 256 level. So you can have 256 minus 1, 255 minus that particular value. So automatically we can see it here, right? So this is a program. So what I have done is I have read an image and I have subtracted 255. 255 minus that image. If the image value is 0, it will become 255, isn't it? If the image value is 255, 255 minus 255, it becomes 0, right? So, so you try to execute this particular program now, and give it in the chat window, right? Then I will know if anyone has executed. So yesterday I told you subplot. Subplot means to display more than one image in a single window, right? So 1, 2 means I am having x-axis just 1 and y-axis just 1, x-axis I am dividing into 2. So totally 2 images will have. So in that first quadrant, right? Now we execute. So it is given in that link, right? Program link. So day 2, the first program, that is this image negative. So actually this image negative, so most probably it will be used for some manipulation. Okay. So actually, negative means you suppose if you have just you are converting high value to a lower value. So in certain images, what happens is in black, if it's full of black, if there is a small variations in that particular black, so in the black itself, if you have value 225 and nearby you are having 255, so the difference will now both are white or both are now black if you consider 0 and 5. So using your normal eye, you will never get the difference. If you convert it into a negative, so if in the black in the white surface, if there is somewhat darker white, we can see. That's what. So just to see the difference, it can be used, or for some certain applications we can have. So anybody has finished the program execution? In that case, I'll go to the next.
Seldev sir,
Ah,
we can continue. They can do after the workshop
yeah,
also.
sure, yeah, they are finished. Okay.
Yeah, few of them finished.
Okay.
So if they have any queries, they can ask to us tomorrow also.
Okay. So someone has asked matte to gray, isn't it? Suppose if you have a binary image, 0 and 1. Suppose if you want to convert it into a grayscale image, so you can use that function, matte to gray. So that will be converting to matrix to a grayscale image, right? That's the purpose of that, right? So next you'll go for log transformation. So next is log transformation. What the log does, so normally you can see it here, right? So the log function. So initially, if the value is 0, what do you infer from this? The main thing is the image will expand its lower value pixel to a higher value and little effect on the higher pixel value. That means, so if the value is high, there will be no major change. And consider the original image goes like this, right? So you have a straight line like this, horizontal, like this. Suppose if you see here, from this your lower value has become a higher, here it has been expanded here. But when you are going for higher values, it has less effect. If you have a line like this, that's what the main application of block transformation. That means if there is some dark region, the dark region will be expanded. That is lower value pixel means lower value means dark region. Value 0 and 5. Likewise, dark region get expanded. Right? Suppose if we have an image where you have to, there is more dark spaces, so we can use this log transformation. So what happens is it will enhance the dark region and it will never there is less effect on the light region, right? So that's the effect of this log transformation. So this is the formula S equal to, so C is a constant, log 1 plus R, right? This R is the pixel value there. So S is the transformed image, right? Assume R, so we'll have this one, right? Log transformation, right? So here what I have done is I have written cameraman image, right? So here you must in this program you have to understand something, right? So log 10 of 1 plus 256 cross that particular image. Why I am multiplying by 256 is, so I converted the image to double format. So would you know what's my double format? Double format means normalized version. So normalized version, that is double precision, I told you before. So for doing any arithmetic operation, first you have to convert it into normalized version, right? So normalized version means what do you do? What if you have a value from 0 to 255, it will be converted to 0 to 1. How it will be converted? 128 will be converted into 1.5 and 255 will be becoming 1. And likewise, so it will be 0 to 255 will be converted into 0 to 1. That's what double will do. So that's what make it into, that's what you're multiplying by the level 256, right? And after that, what happens is, again you have to convert, isn't it? Normalization, the normalization procedure is this one, isn't it? For that is any value minus the minimum value divided by maximum minus minimum. So this is what normalization will do, right? So that image, that is the image what you have got here is in B unit 8 that you are normalizing here again. Since you are multiplied by 256, right? So you are normalizing here, for that only image minus the minimum value divided by maximum value minus the minimum value. That's normally used for normalization. That's what you have done it here. I have done here showing it outside. Just execute this one, you'll see the difference. So you can see the difference here. So I have not given here C value. C value here you are considered as 1, right? So later we can change the C value now. Now it may be 1 here for this program, right? Just copy that code and just run. Automatically it will be run. So in the chat window, just finish, right? And then I'll go to the next. I'll give just 10 or 20 seconds. That will be good, right? Some leisure time. Oh, someone has asked, I'll tell you later, Lakshmi Priya. They asked how to convert RGB to HSV and how to extend the green channel. So I'll tell you at the last. It will take time. So we'll go for the programming. At last, you just remind me. I'll tell you. So if you finish, you can see the difference in light, the cameraman image, right? The dark region gets expanded. You can see it clearly. Yes, someone has finished, and then we'll go to the next one, right? So next one is power law transformation. So normally when you have, say, when you are going for Photoshop and all, have you heard about a gamma correction? So this is what we mean by gamma correction, this power law transformation, right? So what happens is if you are going, if you are having different types of displays, right? So we have TV. In TV itself, we consider earlier we have CRT monitor. After that, we have plasma, then LED, LCD, then LED. Now we are having LED. So there are different types of that is displays available. So if you give your image to the one display that is considered CRT monitor given an image, the same image you give it to a LED, whether the LED looks good? No. So we cannot see that much clarity there in LCD. So what happens is, this is what normally you have to do some gamma correction there, right? So that is done by this power law transformation, right? So this will be done by, so here the general formula is S equal to CR power gamma. So R is that image, C is a constant, right? So what this gamma will do, that's what we have here. So if the gamma value is greater than 1, what happens is compresses dark image and expands bright image. So what you have done seen before, log transformation. What log transformation does? It increases the dark value and has less effect on the higher values. The same some different way here. It compresses the dark value. So suppose if you are having many dark there, you can compress the dark value and expands the light value. That light value means higher values you are expanding. So if the gamma is less than 1, it expands the dark value. So even a small thing in the dark value can be seen if you are expanding the dark value and compressing the high value. Yeah, compressing the bright value. That's what, when the gamma is less than 1, it does, right? We can see the difference here. Just I given you here a program here. So what I have done is, so previously I told you this image 2. This is what my normalization. I given 3 types of things I have given. I have read a spine.tif. That's what IMG equal to IM read spine.tif. Then after that, I have converted into double and multiplied dot power. This is power 0.6. That's what gamma, power gamma, isn't it? So dot power gamma and other 0.4 and 0.3. I have given 3 gamma values, 0.6, 0.4 and 0.3. And I have given, I done the normalization here. After normalization, I am plotting the 3 images. Since we are having 3 gammas, 0.6, 0.4 and 0.3. Just execute this one. You can see this for your monitor, which gamma holds good. Whether gamma 0.6 or 0.4 or 0.3. So that differs from images to image. Suppose if in your monitor some images just don't look good, means you can change this gamma value so that the image will be more visible and you can see the fine that is fine details of that particular image. Just execute this program and put finished. We'll go to the next quickly. Yes, you are finished, right? So yeah, you must be here. You may get the idea now. By just changing the comma value, how the value, how the image changes, right? So next you'll go for grayscale slicing. So gray level slicing means consider this particular image, right? So here, I do not want this particular details and all. I need only this particular details. Likewise, if you consider means, so if we go to IM tool, we can see what are the pixel values here. So if you want to highlight only this particular 3 lines, so you get the pixel value. Only you'll go for, so this particular pixel value, just you're highlighting, remaining I make it to 0. Likewise, you can have, right? So you'll fix up from 50 to 100. I'll show. Remaining, I'll make it to 0. Or remaining, I'll make it to 255. Likewise, you are highlighting a certain range of gray levels just to highlight a particular object, right? So that normally that's what we'll use. So to highlight a certain object, only what you have to do, you get the pixel range of that particular object by IM tool. You can move here and there and can see what is the gray level values there. So after that, what you do, you give that range from 50 to 100. You make it as the original, and remaining values you make it as 0, or you make that limit as 0, remaining as original. So either way we can have. That's what we have it as gray level slicing. So one thing is highlighting a range of intensity while diminishing all the other to the contrast low level, or highlight a range of intensity but preserve all others. So these two regions we can have. So this application also we have mass of water, crop region, or certain evaluation area. In satellite imaging, it may be used, right? So here I given a program here, right? So this rise.png, that's the image I have given. So I have taken that image size. So here you must understand the for loop, right? That's what. So image size means here size of I am taken in 3 variables: row, column, and third one denotes whether it is color image or a grayscale. If it's a grayscale, it will become 1. If it is a color image, it will become 3, right? So I am getting the thing in 3 variables. Then here this particular line T1 means input, enter the lowest threshold value, enter the highest threshold value. So this is all. This will ask you. So if you execute this line, so in the command window, it will ask you enter the low threshold region. You have to enter. You enter some value 50, right? Next again it will ask input, enter the highest threshold value. Again it will ask you whether this you type 100. right? So automatically T2 will become 100, T1 will become 50. So T1 variable will be assigned 50 since you have entered. So this is what input. It will ask you to give the input, right? After that, what you do is you are scanning the pixel one by one, right? Whether it comes under in this area. So for that only you have two for loop. 1:1 row. One means here one denotes the initial value, row means the final value. So you have taken it in the size. See here, you have taken it in the size. So 1:1. 1:1 means middle one shows the step size. What is my step size? If it is 1 means a 1, 2, 3, likewise it goes. If the step size here 1:2 means it will become 1, 3, 5, likewise it goes. But you have to take one by one, right? Isn't it? Row 1, that is I of 1 comma 1, I of 1 comma 2, likewise you have to get. So you'll go for 1:1 row, 1:1 column. Then you are giving if loop. If it is greater than T1 and less than T2. That's what your two things you are given, isn't it? Two threshold value. If it is greater than T1 also and less than T1 also, you have to consider. You have to make it into 255, right? Or else you make a original image let be the same. So for if loop you have to put an end and two for loop are there. So two for loop you have to put an end, right? So if you type for automatically for the next line it will go little further. So you can see it here clearly. So that if you put end automatically it goes back to the same line there, right? Same position, right? So just execute this program. You may be now you'll be understanding this one, isn't it? So this is a basic programming. That is, you are using if for loop and you are getting some input from the computer. So this all of you execute. You'll find if you find it difficult, then you can give the comments in the meeting and a chat window. Since I have given you input also, so it will ask you. So you have to enter it in the command window. Enter the command window and just press enter. Automatically it goes to the next execution. So we'll go to the next, right? So next one is bit plane slicing, right? So here, this might be normally used for watermarking purpose. So to get the bits one by one. So in the first pixel, I want to get the first bit. From the first pixel, I have to get the second bit. LSB, I want to get most significant bit from the first one. means you can get it from this bit line slicing. So each that is what we have it as. So we are representing by 8-bit. Each pixel is representing by 8-bit. Since each we are having 2 power 8, 256 levels there. So we'll represent by 8-bit. So we can get the bit one by one. That's what you get as bit line slicing, right? So you see here, this is the image. So if you are splitting into different, this is the least significant bit, and this will be the most significant bit. You can see most significant bit has more information, right? And LSB has less information. Even though if the LSB all the values are 0 or 1 also, that will never affect that particular image. If you are making all the LSB as 0, so in watermarking you'll do that only, isn't it? You'll watermark in the LSB insertion. LSB you'll add some values, so image will never change. It looks like the same, right? So in MATLAB, what happens is you will be able to get the pixel one by one. So for that you get as bit get is the function used for getting the bit. So here you are reading one image, cameraman, and you can get the first bit. So bit get of img of 1 means automatically as the LSB you will get. So just you are showing that. So 8th one, im, 8, that will be the most significant bit. Right? Similarly, second bit, third bit, fourth bit. So you will be able to get. Right? So if you execute this program, you can see the last most significant bit will get the most of the information. That's what you call by most significant bit. LSB least significant bit. So even though if you are leaving the LSB also, or if you are altering the LSB also, there will be not much effect on the image. Yeah, we'll go to the next one. So now, with this, we'll finish the gray level transformation. Right?
Right?
So next, we'll go for histogram. So I request all to mute the mic. Right. So here we must know first what is histogram. So we'll go for histogram processing only. It's more important in image processing. Right? Histogram. Histogram is what? So in x-axis what do you have and y-axis what do you have? That is important. So in the x-axis, when you are going to say it as histogram, in x-axis you have the grayscale values, right? From 0 to 256. Since you are having 256 levels, in x-axis you will have the gray level intensity values. And here in the y-axis you will have the distribution. So number of occurrences, right? So suppose a pixel value 100 has occurred 1000 times in that particular image, means we have like this. So this figure shows the particular gray level value has occurred how much times in that particular image. That's what distribution we have it in the x-axis. So that is a probability of occurrence, right? How much time it has occurred, each pixel value. So from the histogram itself, we can say, so suppose if we have a histogram like this, so if I say it's concentrated only on the lower region, we can say it as a dark image. From the histogram itself, we can say whether that is a dark image or it's a low contrast image or high contrast image, right? So if it is a bright image, means it will be concentrated on the higher value in between 250 to 256, right? This is a dark region, this is bright region. And if it is a low contrast region, means it will be concentrated in only one area, either dark, high, or in the middle, right? So if it is a high contrast image, it will be equally distributed. So you will have for every, see here, it is equally distributed throughout the values from 0 to 256. So normally when you are going for test image case, so why are they have selected Lena image, right? So most of the test images, what we have is, if you see the histogram, it will be distributed throughout. That's what they are considering that as test images in MATLAB, right? So here you can see. So if it's a high contrast image, the histogram will be distributed throughout, right? So that's what first thing you will have in enhancement. The basic enhancement is histogram equalization. So how we are equalizing? That is, if we are, that is just converting the low contrast image to high contrast image. That's what histogram equalization will do. So example, a simple example you consider. This is an image. We are having grayscale value from 0 to 9. So this is the image and pixel value here. So how you will draw the histogram? So histogram 2. Now the value 2. How much time it's occurred? 6 times. See 1, 2, 3, 4, 5, 6. So 2 has occurred 6 times. 3 has occurred 5 times. 4 has occurred 4 times. So this is the histogram for this particular image, right? So now we can say this is a dark image. It's a low contrast image since it's concentrated only on the dark region. So that is for higher values, there is no values there. So you have to convert it into low contrast to high contrast by process of histogram equalization. So what you do it here, how the process is here, the same thing you make it into graphical representation. This is the graphical value and this is the number of pixels that has occurred. So now what you do is here you do cumulative summation. 6, then 6 plus 5 is 11, 11 plus 4, 15, 15 plus 4, 1, 16. Likewise you write. Then you divide by number of pixels. How much pixels? It's a 4 cross 4 image, so 16 pixels will be there. So you are dividing by 16, right? So you are dividing by 16, and what you are doing is, after dividing by 16, you are multiplying by 9, since you are having 9 levels there, and just equating to the nearest value, right? So it is 3.3, we can have it as 3, 6.1, we can make it as 6, so it comes around 8.4, 8. So what according to this is, that value 2 has transformed to 3, the value 3 has transformed to 6, the value 4 has transformed to 8, 5, 6, 7, 8, 9 has been transformed to 9. Right? Now we have the histogram like this. So the where and all we are having 2, it has transformed to 3. Right? Where and all having 4, it has been transformed to 6. You can see here 4, no, 2 had been transformed to 3, 3 has been transformed to 6, 4 has transformed to 8. Right? So you get a histogram like this. So now you can see it here. Histogram has been mixed throughout the value, right? Isn't it? So this is what the histogram equalization will do. So in my MATLAB, it will be done just by histogram equalization. IMS-EQ will do histogram equalization. That's what in MATLAB, all what you are studying in the, now will be available as function. So it makes you easier to execute. Right? So I have read an image and I have get the histogram equalized, that is HISTEQ of A. Yeah, that will do histogram equalization. So after that, I'm just showing the 4 image. 4 image means input image, output image, and also histogram also I have to show. So if you see the histogram also, only understand. So for showing histogram, I'll have IMHIST. IMHIST means it will show the histogram of A. Right? IMHIST of B means it will show the histogram of the output image. Right? So now you execute this program. So this is important. So just execute this program, will understand what you get. So this is a basic in image enhancement, histogram equalization. So if you have executed this program, just say yes sir or something. You have finished. Then I'll understand that you have executed this program. Just copy it from there, just paste it, then just run. Automatically it will be running. Just in 1 to 2 seconds you will get the output since I have given the code there. So I have used here subplot to show all in a single window. 2, 2 means 4 windows will be there. So in the first quadrant, second quadrant, third and fourth. So 4 quadrants will be there. 2, 2 means, so you have 4. You're dividing x-axis into 2 and y-axis into 2. So totally, if you consider, you have 4. Yes. Someone has executed, right? So you have finished the execution. So I'll go to the next. Next is the same thing, adaptive histogram equalization. Right? adaptive histogram equalization, or we can call it as histogram matching or histogram specification. So three names you can have: adaptive histogram equalization, or histogram matching, or histogram specification. That means, so here when you are going for histogram equalization, so it will generate just one type of output image, right? Isn't it? So just if you get a histogram equalization, this is all the output you will get. But what the user will do is, I want several outputs. Why can't be the histogram like this? Why can't the histogram like this? So everybody will say some rules. So how to specify the histograms, isn't it? So for that only we are having this histogram matching or histogram specification or adaptive histogram equalization. In both, any way we can have, right? So in adaptive histogram equalization, in histogram matching or specification, you will specify the histogram, right? So according to that, the histogram will be there, right? That's what we have as histogram matching or histogram specification, right? Right. So that's what here we have a simple program here. So there is an inbuilt function is to adapt to histogram equalization in the MATLAB, right? So here ADAPTHIS TEQ adaptive histogram equalization. So this function will do that particular thing. This is some inbuilt function, right? So you can build your own function, since you cannot have a single histogram. You cannot specify, isn't it? So there are different specifications you can have. So in 2015 also, I have seen on paper histogram specification using beam theory. Beam theory normally used for in civil department for testing a beam. So if you have a beam, from the upward pressure will give pressure. At what time it breaks, we'll see. That's what beam theory is. Right? So what happens is, here also the same thing. What you do, histogram specification, one type what you do is, you'll push the histogram from the top, so that the histogram which are having peak will come down, so that it will be distributed. As a certain time will finish. So that's one process. In 2015, we had a paper, IEEE paper in image specification using beam theory. Right? So you'll just execute this one. Just change, instead of histogram equalization, adaptive histogram equalization. Just that particular line J you change and execute. You can see the difference. You can see, you just observe the histogram. That's what I want. So previous histogram, it is fully equalized histogram we get, but here we'll never get equalized histogram. So execute and just visualize the histogram. The same thing you give it here in the chat window. You have finished or executed. Okay, you have got that output, right? So you must have visualized the histogram also. You can see the difference. Next is contrast stretching. So contrast stretching means, see here, but mainly this one, darkening the levels below M in the original image, brightening the level above M in the original image. What the thing here you use is, suppose if we consider this as, we consider this as a input gray value and the output gray value. So normally you'll have a straight line like this. So what you do is you'll fix 2 points, one here, and push the histogram upward, and you fix the level here and push the histogram downwards, right? So if it touches the line, automatically it becomes a binary image, right? So that you'll all of you mute your mic. So if you have any queries, you can ask at the last. It's easier, just change that particular line. Instead of I am histogram equalization or adapt histogram equation, you're right, I am adjust. So I use all our inbuilt functions there. So it is easier, just change only one line, it will be executed. Right? Yeah, finish. So next, straight away we'll go for masking. So here with this you compared all the three methods. Right, that is adapt histogram equalization, and you can see the histogram. So here when you see the histogram, which one holds good is for medical images, always go for contrast stretching. Since when you see the contrast stretching, the envelope of the histogram never changes. But when you go for adaptive histogram equalization as well as first one histogram equalization, the envelope changes. So we'll get some loss. So for medical images and all, even a small loss in the image may affect the diagnosis. So always try to have contrast stretching when you are going for medical imaging. For all other application, you can go for histogram equalization or adaptive histogram equalization. Right. Next, we'll go for mask. Right. Masking means Mahamudi. So what you do is you'll put the mask on your face, so that from the outside it will show some other feature it will show, isn't it? The same thing here. What you do is you'll use a mask in order to do filtering. So now we will see about low pass filter and high pass filter, right? Low pass filter and high pass filter you are going to see using this mask. So how the mask work is, suppose if we are having a 3x3 mask as shown here, right? So you are having a 3x3 mask and center element here, right? X comma Y. So what you do is you will move this mask throughout the image in a zigzag manner, right? No, not in zigzag, raster scan. Raster scan you must have studied, isn't it? So you will move from the left to the right, then from the second row again left to right. Likewise it goes. So for the raster scan manner, you will move the mask throughout the image. So throughout the image means this X and Y, this position will be moved throughout the image. So if it is in one position, you will get some output. How you will get output is, I meant here, yeah. So if you fix the mask here, right? Now XY position is here. So what you do is you will multiply that position and the so in the image you will have some values, isn't it? That value and the mask value will be multiplied. So mask value will have it as some consider W1, W2, W3, W4. This is the mask value you have. So what you do is you will place it here. In such cases, what do you do? W1 into this value, W2 into this value, W3 into this value, W4 into this value, W5 into this value. Likewise, you multiply and add. So this is what you have done. Do. So you are going to multiply the corresponding value and add all the values. Right? That's what masking will do. Right? So how the output of X comma Y with this value will become? So this value will be replaced by this R value. Right? If the input value you have placed a mask here, means automatically the output, the central value, this position will be changed to this R value. So this R value will go to here. So automatically this pixel will be changed to this R. So this is what the masking will do. Right? So masking, the first low pass filter, we will say it as this is one type of mask where all the values are 1 or 1/9. Right? We can write it as 1/9. So we can call it as averaging or smoothing. What happens if in the image all the values are 5? Means what happens? It adds all the value and divided by 9. So automatically all the values are 5. The value will be 5. If that is normally this one will be used for smoothing or low pass filter. So smoothing or low pass filter means first you must know what is frequency. So in the image, what is frequency? So this I have shown here 1/9. I am moving the mask like this, right? Like this, you are moving the mask, right? So we are having two types of mask here. Two types of low pass filter. Smoothing filter can also be called as low pass filter. Smoothing filter is called as low pass filter. What is low pass filter? It allows low frequency and blocks the higher frequency or attenuate the higher frequency. That's what low pass filter will do, right? So these are the two types of low pass filters available: box filter and weighted average filter, right? So this way, if you use this particular filter, low pass operation will be done. So first you must know what is by low frequency or what is meant by frequency. So if you generally define what is frequency means number of changes per second. So generally that's what we call it in
sir.
Yes, sir.
Yeah, see, please check whether the audience can see the PPT, because for me it is showing the slide 36 of 65. In the
36.
Yeah, in the chat window also a lot of comment. PPT not visible, sir.
So the contrast stretching. That PPT is
that slide is visible to us.
This one, 36.
Yeah, contrast stretching is visible to us.
Okay, okay. So I'll stop again the PPT and again open.
Yeah, you can try that, sir.
Now you're able to see the PPT?
Wait, sir, it is loading. Yeah, now we can see the contrast stretching slide.
Contrast. Now it goes.
No, it is not moving till now. Yeah, now contrast stretching slide number 37.
37. So I'll go fast masking. 39?
Yeah, now we can see 39.
39, right. So I explained to you about the mask, right? So this is the mask we'll use, 3x3 mask. So consider, so I explained to you just now, I'll take a glance. So what you do is, mask means you will move this mask throughout the image, right? So normally how the mask will be is, center will have a mask like this, the center value is x comma y. So what we have to do is, so every time you will fix the mask on the image value changes. So what you consider here, you are moving the mask now, right, in this position, right? So now the mask value and the current value in the image will be multiplied, right? So the image of W1 into this particular mask image value, W2 into this value, W3 into this value. So automatically what happens, we'll have this one, W1 into Z1, W2 into Z2, Z is the pixel value there, right? So that kind of gets multiplied and you are going to add all the 9 values. So here you consider 3x3 mask, so 9 values we have. So you can increase the mask. Mask will be normally square, 5x5, 3x3 or 5x5, normally the odd numbers, so that the center will have one center, right? So it will be multiplied and the image in that position will be replaced by the multiplication and added value. This R value will be replaced in the output image, right? So the first one is smoothing filter, where all the elements will be 1. All the elements will be 1. Then 1 by 9 into, that means averaging, or taking the average. If you move this mask, that means if all the values are 5, what happens here? 5 plus 5 plus 5, 5 into 1, 5, 5 into 1, 5. So divided by 9, totally will get us center value as 5 only, right? So all of you mute the mic. Okay. So what happens is center value will be replaced by 5. So this is what we call the smoothing filter. So it's how that is done is, So you are moving the mask throughout one by one. So your first initially it will be there, next again it will be there. At that time what happens, the central value will be changed by multiplication and add, and we will be replaced by here, isn't it? That's what done here. So 35 into 1, 35 plus 37 plus 32, likewise you add and divided by 9. What do you get? So that will be replaced by in 37 in this question. Likewise, we will keep on moving the mask in raster scan manner. Right? So here we are having two types of mask, smoothing in smoothing filter, or smoothing filter can be also be called as low pass filter. Right? So now I am telling about what is frequency. Right? So low pass filter means it allow only low frequency and it will attenuate the higher frequencies. Whether it is visible, and sir?
Yes, sir. Visible, sir. You can.
The 3x3 smoothing linear.
Yeah. Low pass filter slide is visible.
Okay. Since they are please share the PPT. That's what. Okay. Right. Now, what happens is the low pass filter will filter out the low frequency component and it will attenuate the high frequency. What is low frequency in an image? So frequency means that's what I told you. The number of changes per second that we call as frequency. In images, we call this changes between the pixel value. So if you are having current pixel and this pixel, consider here, consider this as the image. So you consider 1 and 2, there is some change, isn't it? Change is 1, and from this 2, the change is 1. This 2, your change is 2. So this and all we can call it as a low frequency, since the difference between the pixel value is small. And where we'll have the higher frequency, where in the image when you are having an object or edges, right? So the background and the edge there will be more difference. So that we call it as a high frequency. Normally high frequency means edges, right? Low frequency means the smooth area. All the other smooth area we call it as low frequency component. If it is edges, we can call it as a high frequency component. There's a general one, right? So now we can see we are going to do low pass filter. Low pass filter, what will do? It will allow only low frequency. High frequency will be attenuated. So suppose if we have in an image a sharp edge is there. If you apply low pass filter, the sharp edge will become a blurred edge or smooth edge. That's what low pass filter will do. Since you are removing the high frequency means what? The nearby pixel difference, you are making it somewhat lower. So suppose if it's a sharp edge, so sharp edge means there will be pixel 50 to 200. From 50, then the next pixel will be 200. So the difference will be 150. So when you use a low pass filter, you will do smoothing. So what happens? 50, 100, 150, 200. Likewise, it goes. The edges. So edges will become blurred. That's what the low pass filter will do. When you apply this particular filter, the smoothing operation only will do. Automatically, the sharp edge will become a blurred edge. See it here. This is one application here. Even though it's not visible here, but when you apply a low pass filter, it becomes visible here. Right? This is a program. So a smoothing filter. What happens is, I'm reading an image coins.png. Then I have created a mask. Mask is ones of 3,3. Ones come 3,3 means I'm creating a 3x3 matrix with all the element as 1. That's what ones of 3,3. Divided by 9 means all the value will be divided by 9. So 1 by 9, 1 by 9, all this value will be there. Right? That's the mask For moving the mask through the image, you are having in MATLAB a function IM filter. So IM filter is used for moving the mask through the image. So first in IM filter, we have to give the image, comma, the mask. Right? Just execute this particular image or particular program, you'll understand what the low pass filter will do. And observe, you just observe the edges of the coin. It will be get blurred in the output image. Just execute this program. It's available in that particular worksheet or note, OneNote. Just copy it from there. So after execution, just put here in your chat window, finished, so that I can see you have finished the program. So you have anybody finished that programming? Just put with command in the chat window. You have finished. So after execution of this program, just observe in the edges. There is the coin edges. You can see the output clearly. So anybody have finished? Just copy it from there and just place it and just execute. I think you must have got that output. So no need to type, just copy it from there and just execute. Yeah, someone else has finished, right? So now you must have observed on the edges, right? So edges will be blurred. So next one you are going for is sharpening filter or high pass filter. So by the name itself, you now will understand what's sharpening. So if the edges are blurred, what you do? You'll sharpen the edge. If the edges are blurred, you'll sharpen the edge. So for that you use the
year 1991, the Indian government decided to
for that you use the high pass filter, right? So one filter is the Laplacian filter. It can be used for sharpening. So this is what we have. So four Laplacians are given here, right? So this 4 can be used for high pass filtering. So which sharpen that is, it will sharp the edge, blurred edge. Suppose if it's a high pass filter, if we have an image like this, if you apply high pass filter, you can see the output. So you are able to see visualize the edges clearly. That's what high pass filter will do. So here, you must know in MATLAB, so there are several inbuilt mask available. These are some of the inbuilt mask available in MATLAB. So you can see it in the help, right? So what happens is here I took an inbuilt mask, right? So I have read one image and I have used one mask, FS Spatial and unsharp. That's one mask for sharpening. I take it from the MATLAB inbuilt function and I apply to the image. So I am filter, I is the image, H is the mask. It will be applied throughout the image, right? So just execute this program and observe the output, edges. Just edges you observe. So that's a moon image. So you can get it from the OneNote that it's shared with you. So from that you copy it and run it quickly. So you have got that output. So if you see the edges, see the edges are not clear here. See here you are able to get clear edges here, isn't it? So it shows that you are sharpening the edges. This is a low pass, high pass filter, right? So these two are low pass and high pass filter. Now you have done it is in the spatial domain you have done. So why can't you do it in frequency domain, right? So and also another one thing is here enhancing area of interest. At last we'll see, right? Enhancement in the frequency domain. So in frequency domain also we can do enhancement. The same low pass filter and high pass filter can be done in frequency domain. Now this masking is done in spatial domain. In frequency domain, what you do is, first you'll do some pre-processing and you'll find the Fourier transform, and after Fourier transform you do some filtering operation here. That is filter function will Fourier transform. It will apply to the filter function. After forming after you have a low pass filter, high pass filter function, you give it to a inverse Fourier transform. Again, the image will be converted. Again, now you are converted into in Fourier transform. You are converted into frequency domain. Again, you are converted into a spatial domain image. Right? That's what in frequency domain will do. Right? So you cannot expect the same functions here, since this function you have to define by yourself, right? So we cannot get the function from MATLAB. So for a high pass filter or low pass filter in frequency domain, you have to get this by yourself. So actually, in most cases, they all will be finishing in time domain, in spatial domain itself, right? Why to complicate in the frequency domain? So that's what both gets the same result only. But in certain images, you can do several functions in frequency domain. In such cases, you must define the filter function. So which is, if you want to derive the filter function, you must be strong in signal processing. If you are strong in signal processing, then you can define by yourself itself, you can define the filter function. Then we can do the filtering here, right? So even though I have given a simple program here, right? Low pass filter in MATLAB. So what you do is first you are defining all these steps are you are defining a filter function, right? After forming the filter function, what you do? Just you are multiplying the filter function. That is, you are convolving the filter function and the image. After convolving, what you do? You find the inverse FFT and will get the output. Right? That's what this program is. So that is given there. In there, you can see it in the space is given. I have given the low pass filter. So before that, I want to say this also. Enhancing area of interest also. This also is given there. So what happens is you can enhance a particular area. So region of interest, that is enhancing the region of interest. So Ri of poly means that will consider one polygram. Polygram means normally 4 or 5 any gram you can have, right? So here I have taken values. These are coordinate value 88,33. So that is the first point. 144,33 is the second point. 144,83 is the third point. Just you are connecting the 4. This is a position in the MATLAB. So there is a position of the image. That is pixel position. Yeah, this is a row value and it's a column value. 88 row, 33 column. In that position, you put a point. So you can join that 4 lines, you'll get a square. So in that square, consider it as that's a region of interest. You can do any processing in that square. So here we are done some processing, right? So we are done low pass filtering, right? So here we use ROI filter. You don't, that is previously you use IM filter. See here, you use IM filter here, but here you use ROI filter, that is region of interest filtering. So where you have to give the region of interest, image and the filter, right? So automatically 3 types of filtering is done here. So just to show, otherwise you can go for this one, ROI poly of I. This means this will ask you interactively in that image itself when you're executing, here it will ask you. So you have to fix the 4 points and you have to connect the point, right? So automatically that will be executed. So this is enhancing area of interest. So this 2 you just execute later. So now you will finish the program now. Today program we have finished. If you have any queries, you can ask. I'll stop sharing also, right? So these 2 programs are available there. You can copy it from there.
The participants can ask your queries regarding the yesterday's class and today's class.
Someone has asked, right, how to convert RGB to HSV, right? So if you are converting RGB to HSV, it will be converted to HSV space. Then how will you extract green channel? So whether in RGB image you have to extract the green channel, Lashmi Priya, can you unmute? Unmute and just tell me what you want, really want. Convert RGB to HSV.
Sir, am I audible now?
Yes, it's audible.
Sir, thank you, sir. Thank you for giving the chance. Sir, I read a paper wherein it has been asked to convert the RGB to HSV channel. And from the converted image, we have to extract the green channel. Is it possible, sir?
It's not possible. Since if you are converted, what happens is now it's in HSV space. Huge saturation value, right?
Okay, sir.
In huge saturation value, you don't have a green plan channel there.
Okay. Okay.
So if it is in RGB, we can have.
We can extract. Yes, sir.
Yeah.
Yes, sir. Yes,
So the function is RGB to gray. RGB to HSV. That's the function in MATLAB. Just MATLAB help you type RGB to. Number 2 HSV. Automatically that image will be converted into RGB to HSV.
Okay, sir. Okay. I'll try it, sir. Okay, sir.
If you want to extract the green channel, then you have to convert you can extract the second component, RGB. The second component is green.
Okay. Okay, sir. Thank you, sir. Thank you.
Okay. So in HSV, we have just used saturation and value only. Don't have RGB values there.
Okay, sir. Okay.
Yes. Any questions you have? Someone has asked, if I want to extract RGB values only, so RGB : 1. So that will extract the red value. If you write : 2, it will extract the green value. If you put : 3, it will extract the blue value. Right. So if a green value only you have to extract means the image, if you are representing the image in A, so you will have it as A of : 2. So it will extract the second component. You can save it in another variable and you can use. So my email address is Seldev. I'll type my email address if you want to contact me. Yeah, this is my email address, seldev@xscc.edu.in. You can contact me. So any questions from the participants?
See, I request the participants, you can clarify all the queries. Also, you can execute all the programs at home after this webinar, after this workshop. Then if you have any queries, you can raise it during the tomorrow session. Varun sir, please share the feedback link for today's session.
So one thing you remember when you are going for image enhancement or any processing in image processing, there is no universal processing in image processing. That is, if you are having one enhancement method, that will not work for all the images. So that will be working for a certain images only. There is no universal algorithm or universal segmentation algorithm that will work for all the images. Right?
Kalai Selvi madam, if possible, you can switch off your camera, madam. The feedback link is shared in the chat window. Yeah, Seldev sir, continue, sir.
No, someone has asked email ID. I type again, they are asking. That's what I'll type it again.
Already the email ID is shared.
So anybody have any doubt? You can ask. So tomorrow we'll see about segmentation, and also we'll see the morphological operation which fine tunes the segmentation process. Andrew sir.
Yeah. Okay. Thank you very much, sir. Yeah, Seldev sir, tell me, sir.
So whether the recording session will be shared here?
Yeah, the recording session, yesterday's session, within half an hour we may be uploading. Today's session also we will be uploading before today evening. And the link will be shared in the our workshop web page. I will copy the link of our workshop web page and I will paste it in the chat window. After uploading the video, the link will be shared in this web page. So the participants can bookmark this web page and you can check the recorded session in the evening. Okay, Seldev sir, thank you very much for today's presentation.
So thank you, sir.
Yeah, I also thank all the participants for your active participation. Again, I remind you, with this 2 hours, you cannot be an expert in MATLAB. You can try the MATLAB code at your home. Lot of helps available. At the end of the workshop, Seldev Shah may be sharing the links for the help and everything. Also, you can contact Seldev Shah through email. So you can work at home, then you will be getting more exposure to through this image processing using MATLAB.
So thank you, sir. I am signing off.
Okay, thank you very much, sir.
I will see you tomorrow.
Yeah, I also thank the organizing team members, Varun sir, Joe sir, and Anthony Jones Kumar for their support. Varun sir, whether we have to share anything?
Sir, no.
Okay, how many feedbacks were entered? Please check.
Sir, 23.
Okay. So we can wait for 5 minutes more.
Yeah.
See, already the feedback link was shared in the chat window. Again, I am sharing it. So it is mandatory to enter the feedback every day to get the participation certificate. Varun sir, we can stop the recording, Varun sir.